this is Lilith Harrisburg, and welcome to the screencast.
Hey, folks, this is 8.4. We're talking about simplifying rational expressions. Some of us are excited. And we're also multiplying and dividing rational expressions. Ladies and gentlemen, don't forget the word rational. Rational just means fraction, right? So we're talking about functions and expressions that are fractions with variables in them. I'll define what that means, what this rational means later on. But for now, we just want to take a look at how we work with fractions. Add, subtract, multiply, divide, and simplify fractions, right? Now, this section is really all about one thing. What's it about? Factoring and canceling. It's all about factoring and canceling. You best be knowing how to factor. You better know how to cancel, right? All right, ladies and gentlemen, let's take a look. The first thing I want to talk about is something called restrictions. Ladies and gentlemen, I know that you've been talking about domain on graphs, but this chapter we're going to look at figuring out domains from an equation or an expression. In this chapter, folks, we're going to be looking at fractions. Well, if you recall that a fraction is always undefined if you have a denominator of 0. So if I have like 5 over 0, that's undefined, right? That's an undefined fraction. That doesn't exist. Now remember, 0 over 5 is okay. That's just 0. But this guy is always undefined. Because of that, in this chapter, we always want to look out for values of x that make the denominator 0. Now, the most important thing that you got to remember, because a lot of us forget, is always find your state your domain restrictions before you simplify. Okay? So let's take a look at this. Let's look at some examples here. I've got a fraction right here. It says 2x squared minus x minus 6 over x squared minus 4. Right? All right. So the first thing I want to do is I'm going to say, hey, does this bottom factor? Yeah, it factors into x minus 2 and x plus 2. At this point, I'm going to find my restrictions. Well, if I solved each one of these, x minus 2 and x plus 2, what would I get to, if I set that equal to 0 and solve? Would you read, if x minus 2 equals 0, x equals 2 would be my answer? And if I solved x plus 2 equals 0, I get x equals negative 2. Ladies and gentlemen, if x is either 2 or negative 2, wouldn't that make this denominator 0? That's no good, right? Because that becomes an undefined fraction. So what that means is my restrictions are x cannot equal 2 and x cannot equal negative 2. Okay? Now that I've found my restrictions, I'm going to try and simplify a fraction. Now when I say simplify a fraction, it's the same thing as like if I have 3 over 6, doesn't that simplify to 1/2? Right? But in this case, I've got algebraic expressions. Now I've already factored this first bottom into x plus 2, x minus 2. Does this top factor? We'll see. Let's take a look at this. The way I factor, if I've got a 2x, a leading coefficient of 2, I go 2x and 2x. Now to fill in the end numbers, I say 2 times negative 6 is negative 12. And what multiplies to give me negative 12, that subtracts to give me negative 1. Wouldn't it be negative 4 and positive 3? Right? So I plug a negative 4 in here and a positive 3 in here. Okay? Then I say to myself, hey, does either of these parentheses simplify? One of them has to be simplifiable. Okay? Well, if you look at the first parentheses, aren't both the numbers divisible by 2? So instead of 2x minus 4, that should be an x minus 2. Right? You can try and factor that on your own. And again, if you have a different method of factoring, I don't care. Right? Now, from here, now that I've factored, is there anything identical on top and bottom? Yeah, the x minus 2's are identical. Those cancel. So, my reduced fraction or rational expression would be 2x plus 3 over x plus 2. And I've just simplified that fraction. Example B is a blast from the past. You guys did this in the last chapter. You guys try that one on your own. Don't forget, negative exponents move to the top. All right, this last one, in example C. Now, we know, we've talked about this. If I have two things multiplied, if I have a 3 and an x, right? If I have a 3 and an x, and I want to divide that, right? If I want to divide that by, like, say 6 again, right? Well, if I have multiplication between the 3 and the x, can I simplify the 3 and the 6? Yeah, right? Because, take a look, is the 3, it looks like the 3 is attached, but in the last chapter we learned it's not, right? So if I get rid of the 3, does the x go with it? No, right? But what happens if I have an addition? If I have x plus 3 over, say, 3, right? If I try and get rid of the 3 now, does the x travel with it? Yeah, the whole thing goes, right? So the moral of the story is, with addition and subtraction, you can't cancel out just one of the items, right? So, like in this first example I did, only x minus 2 can cancel with an x minus 2. I can't cancel out the individual x's. Second good example, C. Can I cancel out this top with this bottom? Well, at first blush, it looks like we can't. But what number can I factor out of anything? I can always factor out a 1, but that's boring. But I can also factor out a negative 1, couldn't I? Suppose I factored out a negative 1 from this top. If I factored out a negative 1 from that top, wouldn't this top become negative x plus 5 over 5 minus x, correct? But wait a minute. Wouldn't this numerator, couldn't I flip-flop those instead of negative x plus 5? Isn't that the same thing as 5 minus x over 5 minus x? So don't the 5 minus x's cancel? Give me the negative 1. So the moral of the story is, if you notice that one of the factors on the top and one of the factors on the bottom, they look the same, but just everybody's got an opposite sign, then you can cancel them to get you negative 1. Okay? All right, now, that's how we simplify fractions. Again, we'll talk about B in class. All right? Don't let me forget. Okay? All right, now let's take a look at the next idea. The next idea is multiplying and dividing rational expressions. Okay? Folks, again, we're working with fractions. How do I multiply fractions? I multiply top times top and bottom times bottom. But aren't I allowed to cross cancel? Right? So let's take a look at this. In example A, I've got 2x minus 6 over x cubed plus 4x squared plus 3x times x squared plus 3x over 2x squared minus 7x plus 3. You guys try and factor that on your own. All right. Hopefully, when you factored, you would have gotten these top and bottoms. Okay. All right. Now the fun begins. Do you see anything that's on top and bottom that are identical that I can cancel out? Yeah, that's right. The x minus 3 on the top can cancel diagonally with this x minus 3. I've got an x plus 3 here and an x plus 3 here. Okay. Don't I have a single x and a single x? Yeah. By the way, that's my conscience if you hear that in the background. So what am I left with on top? I'm left with a 2 over what's left on the bottom. This is an x plus 1, and in the second denominator, a 2x minus 1. Okay? And that's how you simplify when you're multiplying fractions. Again, ladies and gentlemen, this guy right here is something out of the last chapter. You guys try that on your own.
Oh, you're a bad boy, Mr. Kong.
You know what, Conscience? You're right. I forgot to find the restrictions. All right, so would everybody agree that my restrictions to this fraction would be x can't equal negative 1 from this bottom, and x can't equal 1/2 from this bottom? Right? Well, you'd be wrong. Because, as I said, folks, you always find your restrictions before you simplify your fractions. So I have to go back to all of these guys and take a look at all of these guys, set those equal to 0 and solve. So my restrictions would be one giant, gigante list of numbers that it can't be. From this first x can't be 0. From this second one, x can't be negative 3. From the next one, x can't be negative 1. From the next one, x can't be 3. And from the last parentheses, x can't be 1/2. All right? Did everyone see that? Guys, I'm telling you, you got to find your restrictions before you simplify. If you just go off of this, you're going to get that wrong. Okay?
But what about dividing fractions?
Good question. Ladies and gentlemen, you know that we never divide by fractions. What do we always end up doing? Multiplying by the reciprocal. For those of you who don't remember, who's the most famous baseball team that you've heard of? The New York Yankees.
Red Sox.
Whenever you get out.
Red Sox.
Whenever you think about dividing fractions, always remember the New York Yankees. Am I going to change that first fraction? No. Am I going to change that division sign? Yes. What are you going to change it to? A times sign. Are you going to change that last fraction? Yes. What are you going to do? You're going to take the reciprocal. All right. So I know that I'm not going to divide by fractions. I always have to multiply by the reciprocal. So when I do this, the first fraction doesn't change, but that changes to a times sign. In the second fraction, actually, I have to take the reciprocal of that. Okay. Again, kids, you guys try and factor this on your own. Okay, this is what you should have gotten when you factor. All right, now the fun begins. What can I cancel that's identical on top and bottom? I see a 2x plus 1 and 2x plus 1. I see a 2x minus 1 and 2x minus 1. I see an x plus 2 and an x plus 2. Anything else? Anything else? I think that's it, correct? So I get x plus 1 over x minus 1. Okay, now the restrictions. Would you read the restrictions? Look like it would be x can't be a half from the first parentheses, a negative a half from the second parentheses, a negative 2 from the third parentheses, and the last parentheses would be x can't be equal 1, right? But again, ladies and gentlemen, hey, here's something important. When you divide these things, these rational expressions, guys, you have to list the restrictions of any denominator you see, including the original denominator. So, you know how we flipped this fraction? Wasn't this numerator once a denominator? So I also have to list these as the restrictions too, as well, I should say. X can't be negative 1, and x can't be positive a half. Now that one's actually already taken here, so you don't list it twice, right? Okie dokie, that's it. We'll see you Monday.